Hi learners! In today's video, you will learn about the different types of angle pairs formed when parallel lines are cut by transversals. The angle relationships will be discussed and will be used in solving simple problems related to the topic. Investigating if lines are parallel or not is also a part of this video lesson. Strategies in analyzing and solving word problems are showcased to let you experience how these are done so that you will be able to successfully answer geometry problems similar to these in the future. If your lesson is on angles formed by parallel lines and transversals, or if you have an assignment on this topic, or if you are preparing for a test in math or a test in geometry in particular, or you are someone who is interested in learning math, then this video is for you. As everybody knows, the representation of a line is as shown, with arrows on both ends signifying that the line is infinitely long. Recall that lines can be named using 2 points on the line or by using a lowercase letter of the alphabet. The line shown here can be named using this symbol or this. Both is read as line M. In a previous episode, we defined parallel lines as lines in a plane that do not intersect or touch at a point. They are represented this way, with the little arrow somewhere within the line. The mathematical symbol for parallel lines is this. For these parallel lines, we can write this expression. This is read as line J is parallel to line L. A transversal, on the other hand, is a line that intersects or cuts parallel lines like this. There could be more than one transversal cutting 2 parallel lines like what we have here. Or there could be more than one transversal cutting more than 2 parallel lines as shown. Now, let us look at this figure again where a transversal cuts 2 parallel lines. When a transversal cuts 2 parallel lines, several angle pairs are formed. The name of the type of angle pairs reveals where they are located in relation to the lines. Let us first name the angles formed using numbers. Okay, so these pairs, angle 3 and angle 6, and angle 4 and angle 5, are alternate interior angles. Alternate means alternating side of the transversal, and interior means between the 2 parallel lines. Since the lines are parallel, the measures of the angle in each pair are equal. That is, the measure of angle 3 is equal to the measure of angle 6, and the measure of angle 4 is equal to the measure of angle 5. Thus, we have to remember these learners. When 2 parallel lines are cut by a transversal, the alternate interior angles are congruent. The converse is also true. That is, when alternate interior angles are congruent, then the lines cut by a transversal are parallel. These can be used to prove if lines are parallel or not. These pairs, angle 1 and angle 8, and angle 2 and angle 7, are alternate exterior angles. The word alternate here means alternating side of the transversal, and exterior means outside of the 2 parallel lines. Since the lines are parallel, the measures of the angle in each pair are equal. That is, the measure of angle 1 is equal to the measure of angle 8, and the measure of angle 2 is equal to the measure of angle 7. We have to remember these learners. When 2 parallel lines are cut by a transversal, the alternate exterior angles are congruent. The converse is also true. That is, when alternate exterior angles are congruent, then the lines cut by a transversal are parallel. This statement can also be used to prove if lines are parallel or not. Next, these pairs, angle 3 and angle 5, and angle 4 and angle 6, are same side interior angles. These angles are located on the same side of the transversal and between the two parallel lines. Since the lines are parallel, the angle pair is supplementary. That is, the sum of the two angles is 180 degrees. So, the measure of angle 3 plus the measure of angle 5 equals 180 degrees. In like manner, the measure of angle 4 plus the measure of angle 6 equals 180 degrees. Again, the converse of this relationship can be used to prove that the lines are parallel, because when the same side interior angles are supplementary, the lines are parallel. The next pair, angle 2 and angle 8, and angle 1 and angle 7, are same side exterior angles. These angles are located on the same side of the transversal and outside of the two parallel lines. Since the lines are parallel, the angle pair is supplementary. That is, the sum of the two angles is 180 degrees. So, the measure of angle 2 plus the measure of angle 8 equals 180 degrees. And the measure of angle 1 plus the measure of angle 7 equals 180 degrees. Again, the converse of this relationship can be used to prove that the lines are parallel, because when the same side exterior angles are supplementary, the lines are parallel. Okay, the next pair, angle 2 and angle 6, are corresponding angles. The same with angle 4 and angle 8, angle 1 and angle 5, and angle 3 and angle 7. Look at where they are located on the figure. This pair does not clearly indicate their location. They are on the same side of the transversal, but one is outside of the two parallel lines and the other one is inside. Take note, they are not adjacent. When lines are parallel, as in this case, we have these relationships. The measure of angle 2 is equal to the measure of angle 6. The measure of angle 4 is equal to the measure of angle 8. The measure of angle 1 is equal to the measure of angle 5. And the measure of angle 3 is equal to the measure of angle 7. In the same manner, the converse of this relationship can be used to prove that the lines are parallel, because when corresponding angles are congruent, the lines are parallel. Apart from those pairs, the following angle pairs are also formed. Vertical angles. The following are vertical angles: angle 1 and angle 4, angle 2 and angle 3, angle 5 and angle 8, and angle 6 and angle 7. We know that vertical angles are congruent, so the measure of angle 1 equals the measure of angle 4. The measure of angle 2 equals the measure of angle 3. The measure of angle 5 equals the measure of angle 8. And the measure of angle 6 equals the measure of angle 7. Learners, we also have linear pairs here, like angle 1 and angle 2, angle 3 and angle 4, angle 1 and angle 3, angle 2 and angle 4. Recall that the measure of the two angles in a linear pair has a sum of 180 degrees. Thus, the measure of angle 1 plus the measure of angle 2 equals 180 degrees. The measure of angle 3 plus the measure of angle 4 equals 180 degrees. The measure of angle 1 plus the measure of angle 3 equals 180 degrees. The measure of angle 2 plus the measure of angle 4 equals 180 degrees. We have other linear pairs here, learners. Try to identify them and write their relationships in an equation form, just like what we have here. I am sure you can do it. Okay, with those basic concepts, we will now check our understanding of the concepts by doing the sample problems that follow. Sample problem 1. Here's the problem. In the figure below, lines N, F, D, and line C intersect line A. Which of the following lines are parallel? So a figure is given. Option A, line N is parallel to line F. B, line F is parallel to line D. Option C, line D is parallel to line C. Option D, line C is parallel to line M. And option E, none of the above. As usual, we begin by reading the whole problem and may read it several times when needed to know what we are looking for, to determine what are given, and to figure out how the given information help find what we are looking for. What are we looking for here, learners? You're right. We are to determine which lines intersecting line A are parallel. What are we given here? We're given a figure with lines N, F, D, and line C intersecting line A and some angle measures at the point of their intersections. To determine which lines are parallel, we have to recall the different angle pairs formed by parallel lines and a transversal and their relationships. Because we are to determine which lines are parallel to which, then we have to consider the converse of the different statements about parallel lines and a transversal. Okay, so we will look at each option and investigate if the corresponding angles formed are congruent as the lines intersect line A. Let us start with option A. Line N is parallel to line F. Look at the figure, learners. Between line N and line F, these angles are corresponding angles. That means that we must know the measure of this angle that is adjacent to 135-degree angle. Take note that the two form a linear pair, and we know that their sum is 180 degrees. So, what number, when added to 135 degrees, gives 180 degrees? You are correct, it is 45 degrees. What can you say now about option A? Okay, so option A is not correct because the corresponding angles are not equal. Therefore, line N is not parallel to line F. Okay, let us look at option B. Line F is parallel to line D. On line F and line D, we have here corresponding angles. The one with a measure of 135 degrees and the other one with a measure of 120 degrees. What can you say about the measure of the corresponding angles here? Right, they are not equal. So, what can you say about option B this time? There you are, option B is not correct. Line F is not parallel to line D, for the corresponding angles are not equal in measures. One is 135 degrees and the other one is 120 degrees. Okay, so let us look at option C. Line D is parallel to line C. Look at line D and line C, learners. What angle pairs do you see here? You are correct. Alternate exterior angles. Now, if the lines are parallel, what should the measure of these angles be? You are correct. They must be equal. Are they equal? So what can you say about option C? There you are. option C is not correct. Line D is not parallel to line C, for the alternate exterior angles are not equal in measure. One is 120 degrees and the other one is 82 degrees. We will look at option D. Line C is parallel to line N. Look at our figure again, learners, and look at where line C and line N intersect line A. If we will utilize corresponding angles relationships in determining if two lines are parallel, then we must get the measure of the angle adjacent to the angle with a measure of 82 degrees on line C. On line C, the angle with a measure of 82 degrees and the angle adjacent to it on the left side of C form a linear pair and are supplementary. So we can get the measure of the angle, right? What number, when added to 82 degrees, gives 180 degrees? There you are, it is 98 degrees. Now, what can you say about the corresponding angles formed by line C and line N? They're congruent. Their measures are the same. What does it imply? That line C and line N are parallel. So we have an answer here. Because we already have an answer, option E is definitely wrong. Okay, what is again our answer to the problem? You are correct. Option D is the answer. Okay, let us go to sample problem 2. Here's the problem. Given that line G is parallel to line H, determine the relationship between angle 12 and angle 16. A figure is given. Here are the options. Option A, same side interior angles. Option B, corresponding angles. Option C, alternate interior angles. Option D, alternate exterior angles. As usual, we begin by reading the whole problem and may read it several times when needed to know what we're looking for, to determine what are given, and to figure out how the given information help find what we are looking for. What are we looking for, learners? You are right. We are to determine the relationship between angle 12 and angle 16. What are we given here? A figure with two transversals intersecting two parallel lines and the different angles formed by the intersecting lines. Okay, so we start with the angles whose relationships we want to determine. Learners, locate angle 12 and angle 16 on the figure. If you need to mark these angles, do it. Look at the figure again. It looks complicated, right? Then we will make it simpler. First, take note that our focus here are angle 12 and angle 16. And we know that these two are on the part of the figure containing the transversal on the right. So basically, we do not need the left part of the figure, right? What we will do to make the figure less complicated is to cover the space we do not need. As simple as that. Here is now the simpler figure. With this setup, I am sure that you can now easily recognize the relationship between angle 12 and angle 16, right? So, what is the relationship between angle 12 and angle 16? Which one is the answer? Is it option A? Or is it option B? Or option C? Or option D? There you are, learners. Option D is the answer. Okay, so we move to sample problem 3. Here's the problem. In the figure below, line A is parallel to line R. Again, a figure is given here. What is the value of X? Option A, 40 degrees. Option B, 60 degrees. Option C, 80 degrees. Option D, 120 degrees. As usual, we begin by reading the whole problem and may read it several times when needed to know what we're looking for, to determine what are given, and to figure out how the given information helps find what we're looking for. What are we looking for, her learners? You are right, we're to find the value of x. What are we given here? We're given two parallel lines with transversals and some angle measures. Okay, so it says in the problem that line A is parallel to line R. Now we will reflect that information in our figure by putting arrows to indicate that the lines are parallel. Okay, so next we will locate angle X in the figure. So here's angle X. To find the measure of angle X, we need to know first the measure of some angles adjacent to it or vertical to it. Recognize that there's a triangle near angle X. This might help us find the value of X. Also, line A and line R are parallel. This information again could help us find the value of X. Let us number the angles inside and around the triangle whose values are not known to make our work easier. Let's go. Remember that line A and line R are parallel. So the angle with a measure of 120 degrees and angle 1 are corresponding angles. That being said, angle 1 is also 120 degrees. Can you follow, learners? Okay, look at the angle with a measure of 140 degrees. These angles and angle 4 is a linear pair. Their sum is 180 degrees. So what number, when added to 140 degrees, gives 180 degrees? You are correct, 40 degrees. So angle 4 is 40 degrees. Look at the figure again, learners. The angle with a measure of 120 degrees near the triangle and angle 2 is also a linear pair, and their sum is 180 degrees. So we can get the measure of angle 2. What number, when added to 120, gives 180 degrees? There you are, 60. So the measure of angle 2 is 60 degrees. Look at the triangle this time, learners. Of the three angles inside the triangle, we already know two angles, right? How can we get the measure of angle 3? You are right. We are going to use the triangle sum theorem, which states that the sum of the interior angles in a triangle is 180 degrees. So what number, when added to 40 degrees and 60 degrees, gives 180 degrees? Right, 80 degrees. So angle 3 is 80 degrees. Now look at angle X and the angle with a measure of 80 degrees. How are they related? You are correct, they are vertical angles. And what do we know about them? Yes, they are congruent. So what is the measure of angle X now? Right, angle X is also 80 degrees. Bingo! We got the answer to the problem. Okay, so which one is our answer again? You are right. Option C is our answer. We now move on to sample problem 4. Here's the problem. In the figure below, FJ divides EG and EI proportionately. The measure of angle E is 86 degrees and the measure of angle I is 30 degrees. If FH bisects angle JFG, what is the measure of angle GHF? Here are the options. Option A, 30 degrees. Option B, 58 degrees. Option C, 64 degrees. Option D, 116 degrees. As usual, we begin by reading the whole problem and may read it several times when needed to know what we are looking for, to determine what are given, and to figure out how the given information help find what we are looking for. What are we looking for, learners? You are right. We are to determine the measure of angle GHF. What are we given here? A figure is given with some angle measures. In the figure, EG and EI are sides of triangle GEI. The problem states that FJ divides EG and EI proportionately. This suggests that FJ is parallel to GI, the third side of the triangle. We will put the little arrows on our figure to show that FJ is parallel to GI. Let's go. We also have two triangle measures that are given. The problem also states that FH bisects angle JFG. The word bisect means that FH divides angle JFG into two equal parts. Again, we are to find here the measure of angle GHF. This is the angle that we are looking for. We will mark it with a question mark for now. Okay, so I think we now understand everything that is written on the problem. We can see that for us to get the measure of angle GHF, we need to get first the measures of the other angles. To be able to do this, we need to be able to recognize angle pairs that are formed by the parallel segments and the other segments intersecting the parallel segments. Let us start by determining the measure of the angle on the right side of the triangle. Look at the right side of the figure. FJ and GI are parallel, and EI is a transversal. That being said, what relationship exists between angle I and angle J? Right, they are corresponding angles. And what do we know about this pair of angles? Correct, they are equal. So what is the measure of angle J? That is correct, 30 degrees. Look at the smaller triangle, learners. Of the three interior angles inside the triangle, two angles are already known. What is the measure of the third angle? How do we get its measure? Right, we use triangle sum theorem, which says that the sum of the angles in a triangle is 180 degrees. So, what number, when added to 86 degrees and 30 degrees, gives 180 degrees? You are right, 64 degrees. So, the measure of the third angle is 64 degrees. Now, the angle with a measure of 64 degrees and angle JFG form a linear pair, and we know that the sum of the two is 180 degrees. So, we can get the measure of angle JFG, right? What number, when added to 64 degrees, gives 180 degrees? You are correct, 116 degrees. So the measure of angle JFG is 116 degrees. Now remember that FH bisects angle JFG, that is, the measure of the angle is divided into two equal parts. So how much is the measure of each angle here? You are right, each angle measures 58 degrees. Now look at the angle with a measure of 58 and the angle whose measure we want to find. What angle pair is this? Do not forget that FJ and GI are parallel. They are alternate interior angles, you're right. And what do we know about them? That they're congruent. So what is the measure of angle JHF? It is also 58 degrees. There you are, we have an answer. Which option is this? You are correct. Option B. There you are, learners. We are done with this problem. I hope you have acquired lots of learnings on this video. There you are, learners. Let us summarize what we have learned in today's video. We have learned that, first, parallel lines are lines in a plane that do not intersect or touch at a point. Second, a transversal is a line that intersects or cuts parallel lines. Third, the sum of the measure of a linear pair is 180 degrees. Fourth, the sum of the measure of supplementary angles is 180 degrees. Fifth, the following are the angle pairs formed by parallel lines and a transversal. A. Alternate interior angles. The angles of this pair are congruent. B. Alternate exterior angles. The angles of this pair are congruent. C. Same side interior angles. The angles of this pair are supplementary. D. Same side exterior angles. The angles of this pair are supplementary. E. Corresponding angles. The angles of this pair are congruent. F. Vertical angles. The angles of this pair are congruent. G. Linear pair. The angles of this pair are supplementary. Sixth, triangle sum theorem states that the sum of the interior angles of a triangle is 180 degrees. That is, the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 is 180 degrees, where angle 1, angle 2, and angle 3 are the interior angles of the triangle. Seventh, when solving a problem, you must read it and may read it several times when needed to know what you are looking for, to determine what are given, and to figure out how the given information helps find what we are looking for. Eighth, if a figure is given, make use of it and modify when needed. It is there to help you analyze the problem. There you are, learners. Hope this video helps. That's it for now. If you have any question, leave a comment below and do not forget to like, subscribe, and share this video to your peers so others will learn too. Bye.